Screen visible, no? Hello.
Yes, sir.
Hello.
Oh, okay, so today we'll see that a cable load on this transmission tower. So see how to apply a cable load on this structure. Go to load and definition and go to a dead load. In dead load, see we have only self-weight load, so we have to add a cable load in X and Z axis. Okay, X axis and in Z axis, in two axes. So select dead load, click on add, and for cable load we use a nodal load. Okay, as a cable load we assign this load as a nodal load on the node, at this node in x-axis and in z-axis. Okay, in x-axis and in z-axis. So first see we give that load in x-axis, that factor is 1 kilonewton. Okay, in x-axis, and add. Yes. Okay, this message will appear because we have analyzed this structure, so that's why it shows message. So Fx 1 kilonewton per meter. Then again for opposite side minus 1 factor, minus 1 kilo Newton load in minus 1 in for opposite. This one is for x positive side. This one is for x negative side. Add. Then 0. Then in z axis, fz axis, we gave 1 factor, add, then minus 1, add, close. See, for go to front view, and for x axis, a positive x axis, see in which direction we have, in this side. At this side we have the x axis, so we just select this node with node cursor. Sorry, at this axis, and select this f-axis and assign to selected node. See, and the other end at this side, in negative side, we give this one minus 1, assign to selected. See, at this side. Then from front view, next we go to in 3D, and for say in z axis we have to give in z axis on 2 nodes at this point and this point, at this point, at this point, assign. See, and for negative we add at the opposite point there. Just click outside, select the opposite points, assign to selected. It again, assign. Okay. See, this way. As a cable load, we assign a nodal load in X, in two side, in X positive and in X negative, Z positive and in Z negative. Then just analyze, run analyze and see. Okay. Done. Then for displacement and load check, go to post processing and see all the load. We have the dead load In dead load, we see all the dead load deflection here. And for reaction, click on reaction. It will show you the reaction or support reaction. And with select text, you have options to move this reactions. At this. So this is a method to give wind load on a transmission tower. Then next, see, we have one industrial roof truss here. See, we have this industrial truss, roof truss, and the units are in feet, 50 feet length, and from center the height is 10 feet. And from top view, see the plan view of hall. According to this truss, we have to create one hall, that is this hall, and the total length of this hall is about 100 feet, because hall dimension is 50 feet length and 100 feet width. Okay, so we have to create first this front view, this one truss model in front view with 50 feet 10 feet height. Okay, and there is 2 feet extra steel we have provided for shading a cantilever view, as a cantilever view. So select a new project space, select unit foot, next, finish. Go to front view and first generate one node. And in x-axis we need 50 feet. Okay, 50 feet joined with node B. Add beam, and then select this beam and go to geometry and insert a node, that midpoint. Add midpoint node. Okay. Select this midpoint and translation repeat in y-axis, that height is about 10 feet. Link step, connect with a beam. Done. Then again select a beam cursor, select all these beams in 4 beams, then go to geometry and click on insert node, and we have to select these options, add number of points. So we need number of point is 3. Okay, number of point 3, 1, number of point 3. Then select again add beam and connect these nodes. From downside. Then next, see, we need a 2 feet extra portion for overhanging beam, this 2 feet both side. So we use command stretch here. Select this beam and go to geometry, and see we have this stretch selected a member option, and we go through a distance from start node. This side is a start node, other side we have end node. So from start node, we give a 2 feet stretch. Apply, done. Then select second beam, end node. From end node, 2 feet, apply. Done. So we have created this truss model in front view. Then go to change the view, go to top view, and in top view select bean cursor and select all the beans. Then go to translation repeat, and in Z axis we need 10 feet and number of step is 10. So we get total length of 100 feet. 10 into 10, 100. Total distance in between that truss is 10 feet, and number of step we need are 10. So link step. See. Then go to front view, and I just select this pins, this end beam, and this end, yes, and just delete this. Then next, if you want to provide any column here, so again go to front view and select this nodes, start nodes and end node. Translation repeat in Y axis. We need minus suppose 12 feet. Link step. Oh. Yes. Then second, go to general for a section property, support and load. So in general, in property, select section database. Because we give all the steel property with section database. In section database, we get all the country codes and steel sizes and shape. And see, we have this Indian code, and we have one more companies that Jindal and Tata Steel you get there. So we use Indian steel, and from Indian steel we select angle, and in angle see we have this sizes, select angle sizes. If you click on this view table, so you can see all the all chord size, their depth, width and thickness of the sizes. Then suppose if I select this one at ISA 200 by 200 by 20 at the steel material, add, close, and then again I need I-shape beam for a column, I-shape steel for column, Indian code, I-shape or W-shape, use just I pick one number there. Then first column, select this column, assign, and then for beam select all beam and assign. See in 3D view. Then go to support, create support, add fixed support, select fixed support in front view, select this column and assign. So then for load and definition, go to load and definition, load case detail, add dead load. Add close. Select this dead load and add one self weight, and then we need a point load. For the roof truss we use point load. So go to member load and see here we have this concentric moment. So okay, I just have to delete this because I forgot to change a unit. So change unit first. Go to general or geometry, change unit in meter before assigning any load. Then go to general, load and definition, select load case detail, add dead load, D. select dead load, add self-fed member load, and in member load we give as a concentric force that point load, and that load suppose minus 30 kilonewton, or we have to give a different load also, like 5 kilonewton, 10 kilonewton, 15, 20, then 25 kilonewton. So suppose minus 5 kilonewton at the end, then minus 10, then 15, then okay. Select self weight assigned to be. Select this concentric point load, and select a node, and select at this node. Select first this. Assign to selected beam or plate. Just delete these loads, I think. Okay. Add. We give a nodal load here. Sorry, nodal load in Fy axis minus 5 kilonewton. Add minus 10. Add minus 15. Add and minus 20. And minus 20. Select F5, then select node cursor and select this node and this node, and select assign to selected node. Save this project and assign this node. Then again second, then 15, just click on this options loads to show this load type, and with shift V we can see that load type. Then go to analyze and print, add, close and analyze. Go to post processing, apply, OK. Result for view maximum displacement beam, display this maximum result, annotate, remove. And see, if you click on summary, so we get this maximum displacement in y-axis minus 4.987, a maximum displacement. And in reaction, we'll see all the support reactions. In beam, we'll see all the bending moment and shear force from it. The blue color will display the shear force, and red color will display as a bending moment. In animations, we see the deflection here on the structure. And in stress, we'll see the stress type on beam or on wall. all these trees in column. See, these are the graph which select this beam and it will show the graph here about bending and shear. All this for column also or for beam, a single beam. If you select any single, it will show the graph here. And see, you can create this industrial roof truss through geometry also. Click on geometry, go to run structure wizard, and see in run structure wizard, you get this truss model. Okay. This one, truss model, total length, height, width, and the number of segment according to length and number of segment according to width. Okay. If you click on apply, see this. Then transfer model for working space, and we get that model. And see for roof like bus stand shading or petrol pump shed or a stadium shed, that shapes are different, like top shape or any different type of shape. That shape, like if the stadium cover is in arc shape, so first we have to create that arc shape in AutoCAD, then we import in StatPro and we analyze it by giving a property and loads on it.
Sir,
Yes.
here we are doing the structure.
Mm.
Take the moment and share,
Mm.
etc. But did not done the design.
Design, which type of design?
Sir, uh, this type of structure, frame structure,
Yeah.
truss structure. We have to do that or not?
Glass
A truss structure. This is the truss,
truss, yes, truss structure.
but did not done the uh,
Yes,
we check the
space.
how much moment and how much stress is there. But after that, we have to design, na?
Yes, steel design
Still
with
design.
IS code 800.
Yeah. In this structure, we did not that. Actually, we selected the members and
Hmm.
uh, is it okay or failed? Not checked, sir.
See, software will not show you it's failed or passed. If there is any failure, no, it will show that warning or error. It will not show you. It all depends on manual calculation. If you are going to create any structure, now you have to do a manual calculation for any structure. Then you'll just come in StatPro and see if that structure is okay or not with your manual calculation.
How we select the sections?
Section?
How we select the section side?
Which
Actually,
section? Mm-hmm.
actually, we first selected the section
Mm-hmm.
uh, uh, for designing.
Yes.
After that, how we change the size of the sections?
Steel size.
Steel size, sir.
It will all given in the code book. It's all are there in code books.
Then we have
In
to do
which type of truss? There is a
manually.
different type of truss, no? I
Uh,
think there is a different like 16 or 20. There is a different type of truss. So according to that truss, it will define that which steel angle or bar will assign. Actually, I have one structure there. Someone is sharing me. And see the plate design in Stat Pro, there is no Indian code for a plate here. So we will do with BS code, British code. File, we'll take the new project. Go to select and select X and Y axis, the X and Z axis. And then go to geometry and sorry, not in geometry because we get here that fill floor grid with plate. Then go to general, define a column beam size first. And point 23. Select the column property and go to select and being parallel to y-axis. Assign these properties. Then select beam. Go to select and beam parallel to x-axis and beam parallel to z-axis. Then assign. Then for plate thickness, click on thickness and plate thickness is about 0.150 mm. Add the material concrete, add, close. Select all the plates and assign. Then go to support and create fixed support. Select in front view, assign. Then next for load and definition, load case detail, add dead load. End life. Select dead load, add self weight, member load, Newton load, And for plate load, pressure on full plate minus 3 kilonewton in GY axis, and in live load we give as a floor, and floor load minus 3.5 kilonewton, 15 meter in Y axis, 12 meter in Z axis, and X axis and Z axis. We have 12 meter. Add flows. Select self weight, assign to. Select member load and go to select beam parallel to X axis. Select beam parallel to Z axis and assign to selected beam. Assign. Then next plate load. Select plate and select plate cursor and select all the plates assigned to selected. Done. And see, for designing, just go through design and just go to concrete design. And in concrete design, see, for slab we use BS 807. This one. And with BS 807, we have to define some parameters. Click on define parameter, and we use one clear. That clear means the distance from outer surface of member to edge of main reinforcement. So it's a clear cover option. So clear cover is about 0.025. Add, and then we use FC, that is compressive strength of concrete, and we use as a 25, or if you are using 30 M30 grade or 40, so give that value here, like 330,000 kilonewton per minute. And FY main, that is yield strength for main reinforcement and steel, we use 50. Add. Then close. Then go to command and give a command for designing as a design slab and element. Add. Then for complete this design, take off, add, then close. Select clear cover and assign assign to view. If you assign to view this clear cover, it will apply on plate or on all concrete column and beam. So I just select that plate, assign, FC, select, assign, and FI main, select, assign, and design element also, select the design element and assign. Then go to analyze, add, close, then analyze, run analyze and save. Then go to view output file and see in result you get this concrete design, RCC design of a slab. A plan view, the section view, the bar detailing, a top and bottom bar detailing, unlimited state of 12 mm bar, 16 mm bar and 20 mm bar, which will be divided in these three parts. Actually, StatPro will calculate beam and column loads and RCC designing, and for a slab there is no code. See, if you try IS 456, we can't get any detailing of reinforcement. Yeah. So mostly we analyze a column beam, in a building structure. And see, there is a load. There is two type or three type of plate loads. No? That is one way and two way. Load definition. Go to dead load and see this is a member load, and this is a floor load. See this floor load. See, click on it. Floor select and see. In floor load, we have these options: one-way distribution load means one-way slab and two-way slab. Now, this all slabs are two-way because we have assigning all the loads in all four sides. See, if you select one-way distribution and click on change, so after analysis, it will assign only a two-way, only a two-side load in one-way slab. Okay, not be generated. Accent. First. Close. Then select 4-node plate, assign. Go to general and see the property, define property. 0.32.30 and assign to B. It will assign only on beams. Then thickness 0.120. Yes. See, if you do assign to view, it will assign only on plate. Then for support, create support, pin support, select all the nodes, assign. Then go to load and definition and see in load case detail, see live load. See, in live load, if you click add and go to floor load, and see in floor load we get these options to one-way distribution. One-way means it's a one-way slab, and if you not check it, so it will assign as a two-way slab load here. Minus 1 kilonewton, and suppose if you give one-way distribution, and we have to assign that range. In x-axis it's 4 meter, and in z-axis it's 3. Add, close. See, this is a one-way unload, one-way slab. And if you uncheck this option, so we get two-way slab. This two-way slab. And overhanging means suppose there is no beam at outside at the one end or at the three end, so it's a cantilever plate. So mostly we use one way, two way. slab in Stratco. So if you want to use one way, so you have to just check these options: one way distribution, close on any slab or any floor. Hello. Is there any questions regarding this? Screen not visible. I just share. Now it's visible. Okay, now see the next tower, this one. We have to design this steel tower as a in meter, and we also do steel designing according to IS code 800. And it in X and Z axis 10 meters. meter at one step and 10 meter. And display dimension 10 meter and 10 meter. Go to top view and select this side node. Go to translation repeat and in x-axis see we need 3 square. One is 10 and second one is 6 meter and the last one is at 3. So we'll add 2 meter. In x-axis no need to link. Okay. And 2 meter from this. In the minus, then select these two nodes in z-axis 2, and from this side minus 2 meter in z-axis. Select add beam. Then select beam again, select these beams, geometry, merge selected member, dimension 6 meter, 10 meter, 6 meter. Then next we need 3. So we select again these two nodes in x-axis 1.5. And from this side also minus 1.5. Then select z-axis, we have 1.5. So in z-axis 1. From this side also select z-axis minus 1. Add beam. Select beam cursor and select this and go to geometry and merge this. Merge selected member. Add. We have 10 meter beam 6 and 3. Then next we have to specify the height 6 meter beam at 18 meter height, and we have 6 meter we have 6 height also. We specify the 6 meter height also, and for 3 we have to specify 3 meter height. So see how will we do. Just go to isometric view, select this. We will go to geometry, move from joint. In y-axis it's at 18 meter. 18. Then we select this member. In translation repeat, in y-axis we give 3 meter at 2 step, total 6 meter link. I just remove the dimensions. Remove. Then select this member, and we need this member at 10, 6, 27 meters. Translation repeat, in y-axis it's 27 meters. This member center. Then select add beam and connect with add beam this all the nodes at top also. Go to front view, select beam cursor and set this beam and remove. In isometric, select all these 4 beam and we need two nodes. So go to geometry, insert node, and number of node we need 2. Then again add beam and connect this. Outside also join this cross section. Then go to general section database. Then go to Indian and select angle. Add this property and assign to view this property on the structure. Then go to support, create support, add fixed support, select this fixed support, go to front view and select this node, downside all 4 nodes and assign. Then go to load and definition and see if you want to assign us wind load, just create the definition. Okay, or I just give as a dead load here. Dead load. Load case 1 as a dead load and a cell bed. Select assign to. And see if you want to assign wind load, just create this wind definition. Select wind definition, add type 1 wind 1, add close, select a wind 1, add calculate as per AC 10, height is about 27 meters, so for category, and we give as a 44 wind speed in meter per second. In C exposure, this is a truss tower. Okay, and give a exposure of 1, add close, then select load test detail and add foresight. wind. In x-axis, in x positive side, z-axis, and z in negative side. Add x in negative. Then select x positive first. Add wind load. In x wind load, that is one factor, and in y-axis we have the height of 27, and no need to give any length or width. Add, close. Negative x, add. In wind load, in x-axis the factor is in negative -1 and 27 height. In z-axis again wind load and z what 127, and in -z wind load is z-axis but factor is in -1 and height is about 20. Select the exposure and assign to the structure. Then analyze and print, add, close. Then go to analyze, run analyze, and see. And for same as a result, go to post processing mode, apply, see in deflection. This is a dead load, this one is as a wind load, and in wind load we have the maximum displacement. Okay, so after analyzing and after all the loads, just go to modeling, and in modeling we have to design it as a steel design, and we choose as a current code steel design IS 800. Then we have to add some parameter. Click on define parameter, and here we use some define parameters. One is FYLD. FYLD, that is yield strength of steel. So we use FYLD, yield strength of steel, we use 25. This one is the same. And then we use LX and LY. Length in local y-axis for slenderness value, that is scale by R, this formula. So we have to give this one, or you can only use FYLD also there in steel design. FYLD and the track option only two. This one we use FY, LY, LZ and LX in for a building structure. If there is a building steel building structure, so that time we are using LX, LY and LZ. That is length in local y-axis and length in local z-axis and local in x-axis. So for this steel tower, I am using FYLD, and one is as a track for result. Track this one. Add, close. Then go to command and see. We have the in command we get the check code, fixed group, group member, take off, select, optimize, and take off. So we select first check code, add. Okay, we don't have any group there, fixed group, or so we'll take a member take off. Then we select this select option and then take off. Okay, it will not show you that bar or angle or any I shape. So we have to see if you make any group there, so you have options to select the group, but I am not making any group. So I select the check code, member take off, because we have member of steel members there, and the select for selecting automatically that structure, and then take off to complete a process. Close. Steel take off. Then select FILD, assign to view, track, assign to view, and check code, assign to view, and steel member takeoff also assign to view. Select, assign to, then take, assign to view. Because we have all structures are steel, so we do all assign to view on a structure, then analyze this structure. Okay, some member size have changed since that analyze. Result. Steel design. See, these are the steel design results. Indian section STIS 200 by 200, that is length, width, and thickness. See, all members are passed. See the last. And see if there any other memberships required, so it will pick automatically. See, if in this tower is there any requirement of any other steel, it will, the Stat Pro will pick automatically that steel types there. It will pick automatically. So this all bars are suitable for this tower. Either it's IS 200 by 200 or ISA 200 by 200 by 12 or 16 or 10 or 8 thickness. So this all types are suitable for this structure. So it will pick automatically this. So we can assign this materials in different this type of tower. We have assigning this one, so it will show us again, so you can use this property also. This is same, and the IS with 12 depth, 16 depth, 10 depth, and 8 depth. Okay, so for steel designing we have this step here, IS 800. Okay, and see if is there a building, a steel building structure, so we have one more, that IS code 800 2007 LSD and WSD there. We have these codes, and IS 801 and 8024, this all code type. So these things are in today class. If you want to practice, just practice it. And if there any doubts, so just ask me. And see, we have to add all these parameters for steel designing, a code or FILD track. Okay, in command we use check code, member takeoff, select and takeoff for steel member. Hello. Yes.
Excuse me.
Yes.
When we go for foundation design,
I will try. Yes. See, if you are not taking advanced structure analysis and designing software in Cloud Campus, so then we'll go. Or if you have picked that advanced structure analysis and design, then foundation design topic will complete in that class. But if you are selecting only a fundamental, STAAD Pro fundamental, so I will try to give that foundation design also.
I was told that foundation will be covered in this.
Who?
Who was that? Whosoever has discussed with me.
Yes. No, no, yes, I will.
So while selecting the course, so
Hmm.
I discussed with someone. So it,
Uh, See,
comes
actually,
and
actually there is a STAAD Pro have three parts here. So sometime I have teach all the advanced topics and all these things there. Then again the students connect in advanced class and they ask me to, sir, we have done this topic, so I will doing this thing again. So that's why.
in advance also what we are going to cover. If we can
Hmm.
have that syllabus, then we
Hmm.
can see.
You have the syllabus of advanced STAAD Pro.
No,
Hmm.
but anyway, I would like if you can do something. For,
Hmm.
we can go for the advance also.
Hmm. Advanced for like yes, for advanced analysis or for advanced designing for RCC or for foundation.
Like grouping, we have not covered.
Hmm. There is see there is a lot of things in the software. Now see we have left two topics: water tank and breeze design. Breeze and water tank. So tomorrow we'll do this water tank designing and steel building structure tomorrow. These two topics: water tank and steel building design with LSD highest score 800 LSD or USD.
Sir, this is RCC water tank or MS? In MS structure?
RCC water tank. And on bridge design, we'll do a moving load. Yes.
Sir, any underground water tank?
In STAT Pro? Yes, there is a underground water tank. Underground water tank, steel structure water tank, rectangular shape water tank, circular water tank. There is any kind of structure you can create and analyze in STAT Pro. Any type. Only this see for structure STAT Pro will give that function. So we can analyze any kind of structure in this software.
Actually, sir, I am working on one underground water tank project, that is ZLD project, zero discharge.